Good day. Today we are going to look at the topic isostasy. The first slide displays the introduction on isostasy. Isostasy is explained as follows. It is a fundamental concept in the geology. It is the idea that the lighter crust must be floating on the denser underlying mantle. It is evoked to explain how different topographic heights can exist on the Earth's surface. Isostatic equilibrium is an ideal state where the crust and mantle will settle into in absence of disturbing forces. The waxing and waning of ice sheets, erosion, sedimentation, and extrusive volcanism are examples of processes that perturb isostasy. The second slide is about principles of isostasy. It is the vertical movement of the Earth's crust as it sinks into or rises from the underlying molten mantle. The numerous plates constituting the Earth's crust on the fluid Earth's mantle and tracked by underlying convection current drift horizontally in a slow terrestrial migration known as plate tectonics. Some of them are also subject to a vertical motion. Presently, in places like Greenland, Scandinavia, or Antarctica, the slow rise above the sea level is of better than a few centimeters per year. Isostasy is the motor responsible for this growth. At any given depth, and to all intents and purposes, the mantle has a quasi-constant density guaranteed within the gigantic planetary crucible by the continuous blending action of convection currents. Principle of isostasy continues. Plates, however, have neither the same weight nor the same density. Oceanic plates tend to be thin and basaltic, while continental plates are generally thick and granitic. Nevertheless, these differences alone could not produce such vertical shifts well as measured within the historical timescale. The motor acting this movement had to be somewhere else. Gravity studies on a global level gave the key to the understanding of this mysterious event. Glaciation or lack of them were responsible for the measurable earthrise from the seas, corresponding to a measurable positive increase of the gravity pull. Again, in this slide, we're going to look at the principle of isostasy. As a brisk change of climate brings warmer temperature to the Earth, the polar caps melt and the water of the defreezing ice mountains runs into the oceans. The affected tectonic plates slowly lighten up and loss relative to the fluid mantle make them surge from the level they had reached under the ice weight to a new, ever unstable equilibrium. Since the climatic change and the melting of the ice is a by far fast occurrence than the vertical adjustment of the plates, isostasy continues for thousands of years after the reduction of the ice cap, provoking a phenomenon whose cause is not directly visible anymore. The below diagram is an area isostasy in which a constant density crust floats on a higher density mantle and a topography is determined by the thickness of the crust. And in the following diagram, it is an area isostasy applied to a real case basin scenario where the total load on the mantle is composed by a crustal basement, lower density sediments, and overlying marine water. And in this slide, the last slide of isostasy, The following diagram is a diagram showing the isostatic vertical motion of the lithosphere in response to a vertical load. Thank you.